Hello, so in today's video, I will continue to talk about what is domain and the function. So last time we talked about what is the domain. The definition of domain is all the possible input of a function. So now I'm going to show you some a basic function or parent. Sometimes they call parent function, sometimes they call basic function, and see what is the domain and the range. So the most basic one is linear function. So what does the linear function look like? The linear function is look like a straight line, right? So what is the domain of a linear function? Look at all the possible value of the input. It's going to be negative infinity to infinity, right? And then range, when you look at range, it look like horizontally because range is all the possible value of the output. So the range will be what? You can go as high as you want as long as you extend in the graph, and then you can go as low as you want. So the range is also negative infinity to infinity. Okay, so what about a quadratic function? What does quadratic function look like? A quadratic function is look like the most basic one, this one, y equals to x squared. This is y equals to x. So for quadratic function, our domain, look at left and right horizontally. That's the domain. You can go as far left as you want and as far right as you want. So the domain is going to be negative infinity to infinity. What about the range? Range, you can go as high as you want. So it will be positive infinity. What about the bottom? The lowest value you can get is 0, right? So the range is from 0 to positive infinity. And then we have a cube function. So a cube function, y equals to s cubed. So the function is look like this one. So just look at the graph and tell me what is the domain of the cube function. Well, they can go as left as they want and go to right as they want. So it should be negative infinity and infinity. Because when you look at these, you need to know, okay, to the far right, it's going to be what? Positive infinity. And to the far left, it's going to be negative infinity. And then goes to far up, it's going to be positive infinity. And far down, it's going to be negative infinity on the y-axis. So that's why when you look at the graph, you need to think, okay, the graph is going to extend to two directions, right? Going all the way up and all the way left. And then also going all the way down and all the way to the right. So yes, this is going to be negative infinity to infinity, similar to the range, also negative infinity to infinity, because you can go as up as you want and go as down as you want. Okay, another basic function would be square root of function. So square root, oops. When it comes to square root, y equals to square root of x, the functions like this one to that direction. Okay, so what's the domain? Well, oh, I make a mistake earlier. So when it comes to this one, the domain, here should be including 0. Not a parenthesis, should be a bracket, because x equals to 0. So y is equals to 0 squared, so y is equals to 0. So similar to here, so you think about square root. Every number in this under the square root has to be greater than 0, right? including 0. So the domain should be 0 to infinity, because you can go all the way to the right, but you can go left, you can have a negative number. So what about range? Range is going to be from 0, because you can have negative number for y, because x can be negative. All the x number has to be a positive. Look at the graph. And start from the origin. You can go lower the y-axis below the below the x-axis. So this should be 0 to infinity. Okay, and next one is going to be absolute value function. So the function is like a V shape, a V. So what's the domain? Well, these are the basic functions, so that means they can extend it as far as they want. So the domain should be negative infinity to infinity. What about range? Well, by looking at the graph, by now you should know the range should be 0 to infinity. We also have our reciprocal function, which is y equals to 1 over x. So the function is look like this one. So when you look at here, tell me, what is the domain? This one is a little bit hard. So let's look at right and the left to find out domain. Well, they can definitely from infinity to infinity. However, there's some value in between, in the middle missing. What would that be? Should be 0, right? Because we know that when x in the denominator, they can be 0. So that means the domain should be negative infinity to 0, and then 0 to infinity. So how can we combine these two sets? So in math, we use this notation, means union. So that means that domain is negative infinity to 0, not including 0, and then from 0 to infinity. So similarly to range, so when you look up, we know that they can go to infinity. And when you look down, we also know that they can go to infinity. But the middle part still missing, because they can be 0. Y cannot be 0. Okay, last one is the constant function. Y equals to number. Like, let's say just 8. Let's use a specific number, constant function. So if y equals to 8, the function is going to look like here. It's 4, 8, 12. So the functions look like this one. Okay. Maybe this is not a really beautiful graph. Let's say the function equals to 8.5. Okay, so what will be the domain? Domain is all the possible input value, right? So let's look at right and the left, because input is x, is horizontal. Left and right, they can go infinity to infinity. So for range, y can equals what? The range only have one number, right? So right in a set, which is 8.5. So now let's say if this is more general, y can be any number, y equals to a letter A, and we say here is our A. That's the graph of the function. It's J9. What will be the domain? The domain is going to be negative infinity to infinity, right? The range, if we write into a set notation, the range should be what? Y, and then y equals to A. Okay, so now let's do more general. So now I have a function, given you a function y equals to 2x plus 4. What is the domain of this function? So if we graph this function, we know that, hey, this function will come from this one, the linear function. They will be very similar. And then the function probably look like something like that, right? So what would be the domain? Domain is going to be x, all the possible value of x. So x can go to what? You need to the left and right. So the domain should be negative infinity to infinity. Range is going to be the same, which is negative infinity to infinity. What about reciprocal function? If I have a reciprocal function like 1 over x plus 4, what will be the domain if you don't know the graph? We haven't learned how to draw the graph of a reciprocal function yet. If you don't have a graphic calculator, how would you do that? So now let's look up. I'm going to use a red pen. So the reciprocal function, why we know that they can equal to 0? Because we know that, hey, everything under the denominator, they cannot equal to 0. Other than that, other than 0, they can be any number. They can be 1, they can be 1.5, they can be 100, they can be negative 8.5, they can be positive 4, positive 1/2, any number except for 0. So if we apply this to here, so I have this denominator. They can be any number. X plus 4 can be any number except for not 0. Right? Because we don't want the denominator equals to 0. Otherwise, the function would be undefined. So this means x not equals to negative 4 when we solve it. We subtract 4 on both sides. So that means the domain is going to be negative infinity to negative 4 union 4 to infinity, because the function can equal anything except for 0, so that we know that x can equal to anything but negative 4. Sorry, I forgot the negative sign. Okay. Again, let's do another example. If I have 4 plus 2x, how do you find the domain? Well, this is similar. There's no restriction on x, except for this part, they can equal to 0. So that means I can have 4 plus 2x equals to 0. And now we solve for x. So that means x cannot equal to negative 2. So that means this function, they can equal to anything but 0. So x can equal to anything but 0. So the domain is going to be negative infinity to negative 2, and then negative 2 to infinity. That is the domain. Okay. What about quadratic function? So when not quadratic, I'm sorry. When it comes to square root of function, x equals to square root of x. If you remember the graph earlier in here, the graph is from 0, including 0, to infinity, because x can equal to 0. So we know that everything under the square root has to be a positive number or 0. So it would be 0 to infinity. But if I'm going to draw the graph like ax plus 4, so what would that be? So again, can x be negative 1? Let's try it. If x equals to -1, so the function equals to y equals to -8 plus 4, which is -2. No, not negative, -4. So no, you can have a negative number into the function. So we keep trying. What about -1.1? So y equals to 8 times -0.1 plus 4. So y is equals to -0.8 plus 4. So y equals to positive 3.2, which still work as a positive number under the square root. I don't know the exact answer. You can use a calculator to do it. So that means what? Sometimes they can be a negative number. Sometimes x can be a positive number. So in general, we want everything in here to be greater than 0, right? As long as they're non-negative, the functions make sense. It will be defined. So I will have 8x plus 4 greater than or equal to 0, and then I solve for x. And then I divide by 4, 8 on both sides, simplify it. So as long as x is greater than 1/2, the function will make sense, will be defined. So that means the domain is from -1/2 to infinity. So now let's try another example. What if y equals to 3 minus 1/4 x? How do you do this one? This is similar to what we did earlier. When we look at a square root, all we need to consider is everything under the square root has to be greater than or equals to 0. Then the function is going to be defined. So I have 3 minus 1/4 x greater than or equals to 0. And now we solve for x. We add 3, subtract 3 on both sides. So I have a -1/4 x greater than or equals to -3. And then how can I get rid of 1/4? So we times 4 on both sides, right? So the 1/4 will be cancelled. I have a -x greater than or equals to -1/12. Okay, and then the negative sign, we divide or multiply -1 on both sides, but the notation is going to be flipped. So x has to be less than or equals to 12. So the domain is going to be what? Everything x less than or equals to 12. So it should be -infinity to 12. So that's it for today's lesson. Let me know if you have other questions.